Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. In the previous video tutorial, we looked at comparing the LandSat and the Sentinel daytime images and data sets. Both have their own good points and they also have their own weaknesses. So it's really up to you to decide which one you want to use. For now, I'm going to stick with the LandSat time series or LandSat data sets simply because I can go back to 1985, 86, and thereby creating an image over a very long period of time that gives me some indication of the change in land use, land cover, features, etc., etc. We also, in one of the previous video tutorials, discussed the issue of spectral signatures, and that is the reflectance from objects on the surf, meaning features. So each feature on the surface will have its own spectral signature, and by analyzing those spectral signatures, we can then identify the feature itself. Okay, so we've also looked at the images, and we displayed it in a true color format. But what we ideally want to do is to take that image and do a land cover classification, meaning to minimize the noise of the image, to make the image more visually appealing, to identify features more easily. We want to take the standard image and we want to convert it into a classification image. Okay, and as I said, the reason is fairly straightforward, that is to make the image more palatable, more visual, and to make it more effective. Okay, so we want to use LandSat to create a classification image, and we're going to do that in the Earth engine. Okay, so we go to our trusty old Earth engine, we go to our code editor, and we go to our coding section, and we then go to the script, and I've saved my script as daytime tutorial 5, and there is the script in totality. Remember, always save and run, save and run. Now, the first thing that we have to do when we want to do image classification, besides obviously generating our images, and we use our standard images that we use for the last number of tutorials. We've got our scaling for LandSat 5 and 7, then scaling for 8 and 9. Then we generate the LandSat 7 image. And important here, I have now need to basically create different time frames. At this stage, my time frames are still basically from beginning to end for each LandSat times a data set. However, it's going to be optimal if we basically create separate images. But nonetheless, let's proceed. So I'm create a median image, a LandSat 5 image for this period with this cloud cover scaled, and I'm displaying the true colors. Doing the same with LandSat 7. I'm creating a median image of the LandSat 7 data sets for this time period. I apply my scaling factors and I visualize it. Okay, so let's, for argument's sake, let's say we make that 2010 and we make this 2011. Okay, so now we've got LandSat 5 not overlapping with LandSat 7. Okay, so let's have a look at LandSat 11. Let's make that 10 and let's make that 09, just for simplicity. Okay, so LandSat 5 will then range from 1985 to 2009. LandSat 7 will be from 2010 to 20. Let's have a look and see. LandSat 8 starts in 14, so let's make that then 2013. In fact, yeah, so we're going to play around. We're going to end this in, that starts in 21, let's say in 12, and that starts then in 2022, and stuff. So we've created now distinct periods. A LandSat 5 period, a LandSat 7 period, LandSat 8 period, and LandSat 9 period, with the longest LandSat 5. We can close, we got, oh, anyway. Okay, so there is our images, and then we basically are going to display the image. And there's our images in our layers, okay, for our region of interest. There's our LandSat 5 image, our LandSat 7 image, our LandSat 8 image, and our LandSat 9 image. Okay, so there's our images, as what we've done before. Now, we need to start our classification process. So the first thing that we're going to do regarding our classification is we need to create our individual ROIs, our individual place features of interest. Okay, that is in terms for Google Earth, Google Engine is then to determine the spectral signatures for each of those locations. Okay, so that's important. And I would suggest that we create at least 50 ROIs for each classification or for each feature or class of features. Okay, so nothing less than, well, not nothing, doesn't have to be less than 50, but I would strongly recommend about 50 and more. And then your classes of features, that is depending on you and depending on your region of interest in general. If your region and if interests have dams, then you should create a classification for dams. If you have mountains, you should create a classification for mountains. If it doesn't have mountains, obviously you're not going to create a classification for mountains. If it doesn't have water bodies, then you're not. So the classification categories will depend on your region of interest and what is in there. But in general, you're not going to create a classification for each and every single land feature. You're going to try to group them just to make to improve the overall accuracy of your classification. So what do we need first? And as you'll see here, I have created 6 classifications categories. I've created a water category, a vegetation, agriculture, a mountain, soil, and urban. Okay, so if I just zoom out, I know the location of my, or I know the geography of my region of interest, and you'll see that it has water, and then there's a river. Let's just undelete these ones quickly. This roughly to activate this, I just go to satellite. Okay, you remember you can view your map either in a terrain format or you can view it in a satellite image. Now, it is important to understand also that the satellite image that you're going to use is most probably quite a newish satellite. So I'll come back to that important point. So there is most probably a mountain. So I have to create a category for mountains. I know I have to create a category for water because there is a river flowing through the region of interest. Obviously, I know that it's very big in agriculture, so I need to create agriculture. I know that there is a lot of open fields or vegetation, natural vegetation, which is used for sheep and goats and the like. So I know, and for rooibos tea and all of these sort of things. So I know there's going to be vegetation. And then obviously, because it's such a dry area, there's going to be bare soil. And then obviously the urban area. So just intuitively knowing my region, and also just by using one of the latest satellite images or satellite pictures, I can identify, or I can first identify my features and then be able to categorize these features into a limited number of categories. Now, the number of categories, again, as I said, depends on your region of interest. Okay, so this is my region of interest. I've broadly identified a number of categories: mountain, river, agriculture, vegetation, bare soil, and urban. Okay, so that is what I'm going to go with. So So I'm going to go with water, vegetation, agriculture, mountain, and so on. And you'll see I've created 63 rows for water, 68 rows for vegetation, 81 rows for agriculture, 57 rows for mountains, 45 rows for soil, and 76 rows for urban. So that is all the individuals. So if I go and activate them, you'll see there is my regions of little rows for each of those categories. Okay, you'll see if let's zoom in a little bit, make that a bit bigger. Okay, you'll see that water is blue. So all these blue rows are water. Vegetation is green. So all these green little markers, I'm going to go through that now. All these green markers are vegetation. This yellowish color is agriculture. So all these markers refers to agriculture. Agricultural features, mountain is 56. This brown colors here. They are all the mountains. And soil is the whitest. There's my soil. And then urban is this red. There's my urban areas. Okay, now you don't have to obviously select each and every single feature. You select a good sample of these features. Okay, and I said these samples are generally accepted to be about 50 and more per feature or category of features. So there's all my features in my region of interest. Okay, so let's quickly zoom into this particular area just to see, and this is where we now need to be a little bit careful that when we look at this, the satellite image and let's say the layer. Okay, so now remember I want to create a classification for LandSat 5. Okay, now again, you can choose which LandSat you want to build of a classification. That's totally up to you. But in my case, I want to build a LandSat 5 classification. And we know that LandSat 5, we go to a time frame, our LandSat 5 is most probably somewhere, the median will somewhere be in the 1990s. Somewhere there will be our median classification. Let's say 1995 for argument's sake. For argument's sake. Let's say our medium classification is around 1995, thereabout. But this satellite image that we're presenting here is most probably about 2020. So I cannot use this satellite image per se to identify my features because some of these features would be very different in my LandSat 5 image. And that's simply because could have been a drought, it could have been very rainy season, it could have been an expansion of housing, whatever the case might be. So you cannot simply use your satellite image to generate your features and then relate it to LandSat 5 or 7. To some degree, you can relate it to LandSat 9 and 8 because it's going to be highly correlated, the LandSat 9 image and the satellite image. But between LandSat 5 and 7 and this satellite image, there will be very low correlation, not very low correlation, but not a direct correlation. So just take note of this, be very careful of this specific point, that we just don't use this satellite to identify features and then assume that features are also present in LandSat 5. It may or may not be. Okay, anyway, so you can see here, we've identified, remember the blue is the river, and you can see if we drill in, we go in, you can see that the blue, let's just wait for the LandSat 5 image to, you can see, let's just wait for the LandSat 5 image to appear. Okay, and this is again, I think, where Sentinel is a better option to use. However, Sentinel is only available, fairly recently. Okay, so if we see there's the river, and we've placed our markers in the river. But as I said, we need to make sure that that river was there in LandSat 5 image. So we overlay that with LandSat 5 to make sure that these markers covers the LandSat 5 image. You can see there we may be a little bit off target. You can see there's one. We actually needed to bring it a little bit more in, because in the satellite, it is in the river for sure. But if you look in the image, it's not at the water. That could be because there would have been maybe a low tide or whatever. I don't know. Could have been many reasons. So this actually needs to be shifted to the left. That's a good indication of what I mean when I say we must map our features using the LandSat, but we can use satellite images to help us. Okay, so there's our water features, or water ROIs that we have indicated we're going to use. There's our red, and our red is our urban features. Now again, the LandSat image doesn't really just present it very nicely in this phone. We know that we can use the satellites, but again, we must be careful that to make sure that these houses was actually there during the LandSat 5 period. Wasn't assumed that it just was. Okay, but anyway, if I zoom out a little bit, you can see if I increase the resolution size, that it most probably will show that in this image there was urban structures. So we can do the same for the bare soil. You can see there is bare soil. It's definitely clear within the satellite image LandSat that there is bare soil. We can see that the green is vegetation. If I just untick it there, you can see there in the satellite image and in the LandSat there seems to be correlation between those two. Okay, now just also bear in mind that when you identify urban and bare soil, to make very clear that you be as precise as possible, simply because the spectral signature between the two are so closely related. So it's very, very important that you create your urban ROIs very precise, and your bare soil ROIs very precise as well, so that you minimizes the chances of there being any overlay or alignment between, because their spectral signatures are so very, very close. Okay, so there's some of that. There is my vegetation. The blue is the water. Green is vegetation. Red is urban. White is bare soil. So let's have a look further upon. You can see, let's go into this specific area. You can see the mountain is red. Now again, be very clear when you do the mountain, so that you don't select the vegetation part of the mountain. So like this, you can see that one there is the vegetation part of the mountain, which is very similar to this. So the spectral feature or the spectral signature of that place, and this will be very similar. Okay, so just be again very careful where you place your little ROIs or your markers, so that you don't have, for the same spectral signature, different features. Okay, so there's our agriculture. You can clearly see agriculture is very distinct. There's another urban area there. There's some water bodies there. There's some vegetation there, etc., etc. Okay, so we've now created, and you'll see here, this where it becomes a little bit complex again, because we know these white circles are potato farms. So they're actually agriculture, but in our image, they represent bare soil. Okay, so again, we're going to have some classification errors there. Again, be very careful to simply assume that if the satellite image says it's X, then in our LandSat it will be the same. Remember, our LandSat 5 is way prior than our satellite. Okay, so those are all our little region of interest or our features that we're going to use to do our classification. I said we've got 5 categories: 6, water, vegetation, agri, mountain, south, and for each one we've identified a number of features, a number of little ROIs. Okay, now how do we do that? Very straightforward. We go to remember, we're going to use this marker here. Okay, we're going to use this marker option, and we're going to use geometry option. So let's say I want to add features or a category of features, like for example, water or vegetation. Okay, I want to add a seventh feature or a classification. Okay, let's say I'm going to take, let's say we're going to go potatoes. Okay, we know these round circles are potatoes. So I'm going to go to new layer. Okay, so I'm going to click on new layer. It will give me an option. I'm then going to click on this nut here, and it will give me my little window. So I'm going to go there, say potato, potato. Okay, so I'm giving it a name. Again, that name is totally up to you. It's your discretionary. Then importantly, because I'm going to elect more than one, I want to create a feature collection. Collection means there's many of them. So there's going to be many different rows or features that is linked to potato. And I'm going to create a feature collection. Then I'm going to have a property ID. And my property ID is class. And this will be the seventh class. Meaning the other classes is, and I'll show you now, is that now the property here, you can call it whatever, as long as they're all exactly the same. And then we're going to choose a picture for it. Let's say I'm going to go pink. And we press OK. Now it sits there. There it sits. And it's highlighted. Remember, if it's in black, it's highlighted. Now it's urban is highlighted. So I highlight it by clicking on it. Now I'm simply, you'll see now, if I unhide it, you'll see my cursor is a little hand. But as soon as I highlight it, it's activated. My cursor is a little cross. So now I'm simply click on each one, and it should give me a little marker. Remember, and I'm going to click like this for 50 times or 60 times, whatever the case might be. So that's now potatoes. So I highlight each and every one of them. Remember, I'm using my LandSat image to identify, not my satellite image, because I don't know whether they were there or not in the satellite. Okay, so that's why I use a LandSat. Okay, so let's say I'm stick with that. Now I'm happy with it, and I click on it so that it is now activated. You'll see there's nothing there. My hand, my cursor is now the little hand. If I want to change one, for example, if I want to change one, I want to delete it. Make sure that it is off, that it's not highlighted. Click on one, and it should come up there. And now I can delete it, or I can redraw it. So let's go quickly to that one there. And let's quickly remember that was this one here when I said it's not perfectly aligned, which is this one. And I want to click on it, and I want now to draw it a little bit. Okay, so I'm drawing it to there. You see now it is within my LandSat band and not within my image. You can see this one here. Let's make it. Click on it, so it's highlighted, and I just move it to there. You have to be very precise with this. Okay, and then I just click on it again, and it's deactivated, and my little thing is away. Okay, so very importantly, okay, now I'm going to delete it again. So I'm just click on this nut. I don't want it. So I'm just going to delete this feature collection. Okay, and it's gone. So let's have a look and see. If I go to water, I highlight water, I click on the nut, and you'll see it's class, and it's one. It's water feature collection class 1, and it's that blue color. I press OK, and I can add more water if I want to. I can, let's say, add another one there. I can add another one there. For example, let's say I don't want it. I've got it wrong. I deactivate it, and I click on it, and it will give me, I can either now edit it, or I can just delete it. That's up to you. So if you want to edit it, move it, or delete it, or whatever, make sure that it's not highlighted. Okay, make sure you've got the little hand cursor, and click on the hand cursor, and you should be able to use it and exit. Okay, if you want to add more, you highlight it, you'll see it's a point drawing, and now you can just go and tick, tick, tick. Okay, so let's just unselect it. Now I can go and click on it and say, I want that one delete. I can click on that one and I want that one delete. So once you've done it, it's important to go and edit them to make sure that they align with your LandSat 5 image. Okay, so we've now created our little ROIs for each of these categories of features. Okay, and we said we're using our marker option, our add marker to generate our ROIs by using our new layer. And there's a couple of important things that we must remember in our layer, and that is we need to give it a name. We need to say it's a feature collection, meaning it's a collective of points. We have to give it a ID. In our case, we're using class. And then we simply just give it each class a specific value and we choose our color. Straightforward, nothing to it. And then, as I said, important part is we need to play around with these features so that they represent a specific spectral signature. And the key here is that there is no overlaps, or we try to overlap them to minimize the overlap on the spectral signatures between the different classes. Okay, and we know that there's quite a big overlap between the spectral signature of soil and urban. So we have to be very clear that when we allocate our ROIs, our urban ROIs and our urban soils, so as to minimize the spectral signature similarities between the two. So that's quite important. Okay, so now we have loaded our LandSat 5 image, our medium LandSat 5 image, which is unique to the LandSat 5 data set. We've loaded that. And then we've identified our number of features, in this case, 7 classes or 7 features, classes of features. And then we've, for each feature, have selected at least 50 regions of interest. Okay, and we do this for this geometry input window. And then we can shift it, move it if we see that it's not at the right place. Okay, so yeah, so next video we're going to do the actual classification itself. In this video we just basically presented the idea of classification and creating our features and our ROIs for each of the features. So stay tuned. Next video, we'll do the classification itself and look at the accuracy of our classification. Thanks for staying at the course. Thanks for joining me on this remote sensing journey. I look forward having you on board for the next one, and I see you on the other side.